Alright guys, welcome back. We're going to dive into quite possibly the first interesting thing in statistics. And this formula may look a little bit cumbersome to you and of headache, but we're going to explain this very clearly in this video. Okay? So just take a look at it. Made sure that I've written it on this board by itself. As I said before, it may look a little troublesome to you, but when we get into the actual problem, you're going to see clearly what it is all about. So it's very, very simple. But for now, just look at it for face value. All right. So I'm going to move this out of the way. And we're going to take a look at here. Now, here we have ungrouped data. And the focus now is to be able to calculate the mean for ungrouped data, and you've actually did that in the video that you looked at before, this one. So we're going to be calculating the mean of this data set. Very straightforward, and of course it's ungrouped data. There are no classes present here, so it's ungrouped. Now, in order to calculate the mean would be equal to the sum of these numbers divided by the amount of numbers that we have. Okay? The sum of these numbers divided by the amount of number that we have. So 3 and 7 would give you 10. 10 plus 2 would give you 12. And 8, 20. Here we have another 10, so that's 30, 31, and 5, 36. So the sum of these numbers would actually be 36. So the total is 36. So we've added all these numbers together. We've got 36. Now we have 1, 2, 3, 4, 5, 6, 7, 8 numbers. So we're going to divide that by 8. So very straightforward. 36 divided by 8 gives you 4.5. So this is actually 4.5. So that's what the mean is for this data set. 4.5. Pretty straightforward. Now let's go back to this guy right here. So we're going to look back at this formula. I'm going to start talking about this formula in a little bit. So we've calculated the mean, we've added the total here, and actually divided that total by the amount of numbers 1, 2, 3, 4, 5, 6, 7, 8, and we had 4.5. So keep remembering this value as the value for the mean for this ungrouped data set. Now we're going to come back to this formula, and I'm going to explain what this is all about. Now, what we did here is this, in essence. What we did here, this very simple working out, is this, in essence. What do I mean? This here, this X here with a line above it, is a symbol for mean. So this actually means we're calculating the mean. That's what it means. So this symbol means mean. So mean means this symbol right here. Mean. So the mean is going to be equal to the sum of f times x divided by the sum of f. So the mean is equal to the sum of f times x divided by the sum of x. Now what does all of that mean? We're going to explain that now. But for now, I'd expect everybody to know now based on what I said, that this symbol here, this x with a line above it, not just an x alone, an x with a line above it, is a symbol for mean. So the mean is equal to the sum. This symbol here, I'm just going to write it here. This symbol here means a sum of. So the symbol here means a sum of. So the mean is equal to the sum of f times x divided by the sum of f. Now, let's explain that by looking at this tally table or frequency table here. Now, I've indicated the scores here, and that tally is just a check off. So for example, if you see something occurring, you just keep checking off. And I'm sure you're familiar with something like this. I'm just going to do it here. Like if you do something like this, you're seeing something and it occurs 5 times and you do something like that, right? That's what we call a tally or a check off. Now, I'm going to just use this table here to explain this formula, because if this here is the same thing as this formula, then we should get the same 4.5. So this symbol here is for mean. This means sum of f times x and sum of f. Now what you're probably wondering now is what f and x are all about, and that's what we're going to discuss. So here's a tally table for this ungrouped data set. Now how many times do you see 1 occurring in the data set? 1 time. So we're just going to put a stroke for 1, and the frequency is essentially the same as a tally. Frequency means how often something is occurring. So, and I'm actually going to call the frequency f, and I'm sure you're seeing f up here. So I'm going to call the frequency f here, and I'm actually going to call the score x. So I'm calling the score x, and I'm calling the frequency f. So I want that to stand out first of all. So let's get into it now. So whatever the tally is, that's essentially the frequency. So frequency means how many times do you see 1 occurring in the data set. So really and truly, I didn't really need a tally column, but I'm just making you aware because some questions in some textbooks will have the tally column. So the tally is the exact same thing as the frequency. So let's look at 2. How many times is 2 occurring? Let's look at the data set. So 2 occurs here, so I put on 1 stroke, and 2 occurs here as well, another stroke. So it means that 2 occurs twice in the data set. Let's look at 3. I'm seeing 3 here, not seeing 3 again, so it means 3 occurs 1 time in the data set. Let's look at 5. 5 occurs here, I don't see it again, so it means 5 occurs 1 time in the data set. I see 7 occurring here, I'm not seeing it again, that means 7 occurs 1 time in the data set. And I'm seeing 8 here, and I'm seeing 8 here, that means 8 occurs 2 times in the data set. So I hope everybody is following. Okay? So, now, remember that these scores represent x, right? And f is a frequency. And I'm pointing out f and x here, and I'm sure you're seeing f and x in the formula. So, this last column now says f times x. So we're simply multiplying whatever value f is by whatever value x is. So 1, which is x, times f, which is 1, is simply 1. 2 times 2 is 4. 3 times 1 is 3. Why am I multiplying? Because that's what it says that we're to do. Multiply f by x. 5 times 1 is 5. 7 times 1 is 7. And 8 times 2 is 16. Alright? Now, this here column is f. And remember we said that this symbol here means the sum of. So, the sum of the frequency would be adding all of these values up. So it would be 2 and 1, 3, 4, 5, 6, and 2, 8. So the sum of the frequency equals 8. And I'm hoping persons are starting to put things together now because you're seeing an 8 here. So 8 represents the total numbers in the data set. That is exactly what the frequency, the sum of the frequency is saying. The sum of the frequency must add up back to all the numbers, all right, or must equate to all the numbers in the data set. So the sum of the frequency is simply adding up all the frequency, and that's it. Now, this is f times x. Now, what I want is the sum of f times x, which means I'm adding up all these values here, which is f times x. So, 1 and 4 is 5. 5 and 3 is 8. 8 and 5 is 13. And 7, 20, and 16. That's 36. And I'm sure you're seeing 36 right there. Now, let's get back to the formula where we're finding mean. So the mean is actually going to be equal to, and this is the symbol for mean right there, is going to actually be equal to the sum of f times x over the sum of f. Now we already know what the sum of f times x is. That's 36. And we already know what the sum of x is, which is 8. And of course, 36 divided by 8 is 4.5, which is what we got here. So, gentlemen, all of this here is just an elaboration of this very simple thing. And you might be asking then, why in God's name we need to learn this if we cannot simply do that? And that is where this comes in. So we're going to come over to here in a second. But again, this formula here that we put on screen at the very beginning means the mean is equal to the sum of f times x, and f is a frequency and x is the score, sum of frequency. Now, I'm indicating x as score because what I should have said in the beginning were, let's pretend that we're a teacher and you gave a test to 8 students in your class. You know, we're doing social distancing, so the class only have 8 students in it, and you gave them a test and marked it out of 10, and these were the scores. So that's why I'm using the term scores, which I should have said at the beginning, but I can do it now. So these values here in the data set would represent the scores of 8 students in a class who did a test that was marked out of 10. So that's why I'm calling this score. Okay? So again, the mean is equal to the sum of f times x, which means frequency times score divided by the sum of the frequency. All right? Now, here is where it gets a little bit more interesting now. Now, what I just did was for ungrouped data, right? We had the values here in the data set. Now, what I'm going to do is now turn our attention to showing you how to find the mean when we're dealing with group data. And if you went back to lessons 1 and 2, you'd understand what I'm talking about. So this here would represent a class or group, and this here would also represent a class or group. So we have 2 groups now. So what we're going to be doing is actually using this data to fill out this table, right? And then we're going to touch on the significance of the group data here with regards to how we're going to find the mean. Now, the score, here we have the class. So we want to find the frequency. Again, the frequency is f. Now, the big difference between the group data now and this one is that in the ungrouped data, I call the score x. But I'm definitely not going to call the score x in group data because the score is not specific. I get a class. These values were specific, only one. So I could have called it x, and I'm going to explain further what we mean as we go through this. Now, so this is a class or a group, and this is also a class or a group. So the big question is this now. Looking at the ungrouped data, right? How many times are we seeing values that occur from 1 to 4? Well, that's very simple. So this one, this one, this one, this one, all of those would run from either 1 to 4. So these values here would definitely fit into this category. So we have 1, 2, 3, 4. So 4. So the number of scores that occur from 1 to 4 is 4. So we have that value. And the number of scores that occur from 5 to 8, well, that would be 1, 2, 3, 4, and that's 4 as well. So now we have this information here. Now what I want to do, guys, is the reason why I'm using the same ungrouped data is to show you that when we're trying to find a mean for group data, that it makes sense because I'm using the same data set here to show the connection. But the reality of it is in real life, you won't see this. So they just give you this information and tell you, all right, so a teacher administered a test among 8 students, and the test was marked out of 10, and 4 students got from 1 to 4, and 4 students got from 5 to 8. Now the problem with group data is that it's not specific. We kind of have an idea because we saw this data set, but if I even cover it, it might be difficult to remember for some part. Now, a big question is, when you have the group data like this, you don't really know the exact individual scores of these 8 students. So even though we say 4 students score from 1 to 4, we don't really know if it is 4 students get 1 or 4 students get 4 or 1 and then 2 and 3 and 4. We don't really know. So that's where the problem is with group data, which means that when we're doing mean, it has to be an estimate because we don't know the specifics. But I've chosen to make the connection with this one because we're going to say how accurate the estimate is. And that is very important. Now, that's the frequency. Now, the midpoint is what I'm going to call x, right? And the midpoint is simply the midpoint of this class, right? That's what it means, the midpoint or middle value of the class. Now, if I look at this class 1 to 4, it's 1, 2, 3, 4. Right? What's the middle value? Well, I'd have to add these two together. 2 and 3 is 5, and then divide them by 2. I will get 2.5. So the midpoint of this class or group would be 2.5. Right? This one again, 5, 6, 7, 8. The middle value or midpoint would be the sum of these two divided by 2. So 6 plus 7 is 13, and that is 6.5. So the midpoint of that class is 6.5. We're going to get back to midpoint in another class, another session, another video. All right, if you're not clear. But the midpoint just means the middle of the class. All right. Now, if the midpoint, if we had a class, for example, like this, 1 to 5, if that were a class, then we would have values 1, 2, 3, 4, 5. And the midpoint would simply be 3 because we have an odd number. Because we have an even number, we have to add these two and then divide by 2 to get that 2.5. So 2 and 3 is 5 divided by 2. 2 is 2.5. 6 and 7 would be 13 divided by 2. That's 6.5. So we have these values as a midpoint. So note now the big difference. With the ungrouped data, the individual scores are X. But with the group data, it is the midpoint of each class that is going to be called X. Now, F times X is simply multiplying this value by this value. So 4 times 2.5, well, that's just 10. And 4 times 6.5, so 4 times 6.5, well, that is 26. Okay? So we're going to come down here again. The sum of the frequency, we'll be adding these two together, and that's 8. And the sum of F times X, because this is F times X, so the sum would be 10 and 26, and that 36. And everything should start to look a little bit familiar to you now. So, because it's grouped data, and even though it looks like it's going to be very accurate in this particular case, it's not that accurate sometimes, but it is accurate enough. So what I'm going to write, because it's group data, I'm going to write estimated mean is going to be, and this is the symbol for the mean, and that's going to be equal to the sum of F times X divided by the sum of F. And the sum of F times X is 36, and the sum of the frequency is 8, which gives us an estimated mean of 4.5, which is what we got here. So what is the emphasis? Understanding this formula, which represents the mean. And also, we can clearly find the mean of ungrouped data, and we can also estimate the mean of grouped data. Okay? And that is what this formula is all about. And the reason why I opted to do ungrouped first is for you to understand that this formula, this fancy formula here, is just this in a nutshell. But when does this apply some significance? When we're dealing with group data and we don't know the specific scores, and then we have to apply the formula and try to determine an estimated mean, which is accurate enough. In this particular case, it's very accurate. And I just want to point out that the classes also, whatever classes they use or groups, will determine the accuracy of the final answer. All right? And also, just a reminder, with the ungrouped data, X are the specific scores or values, and in group data, X is the midpoint. The frequency is always F, frequency is always F, and of course, once you know F and X, then you can figure out what F times X is. All right? Now, I hope you guys found this video insightful, and I'll see you guys on the next video. I'm going to be posting some questions, and let's see how you can tackle that in terms of what we discussed so far. So I hope this was helpful. Please review the video as many times as you want, and give me some feedback and comments as it relates to that. All right, guys?